This is a lesson for the performance tasks, numbers 1 and 2. And so these problems are similar to what you're going to see on that performance task, which counts as a homework assignment and then the test the following day. So let's take a look at the first problem. It talks about how John is biking to school, and the equation 28 equals 36 minus 2/9 m can be used to determine how many more minutes m he has left to bike. And so what we want to do here is we want to solve an equation, and we've got our equation right here, so we're going to go ahead and rewrite it and then get the m by itself. And so my first step is going to be to subtract that 36 from both sides, and notice that I'm taking away more than what I started with, so it's going to be negative. So make sure you put the bigger number on top when you do subtraction, otherwise sometimes you'll make an error. So I do end up having to borrow, and that leaves me with 8. So it ends up being negative 8 equals negative 2/9 m. Make sure you bring down the sign that's in front of the term right there. So from this point, I'm going to multiply by the reciprocal. So I'm going to multiply by negative 9/2. And I do that on both sides. So I'll do the same thing on this side. And what that'll do is it'll get rid of the 9s, it'll get rid of the negative signs, and it'll get rid of the 2. So I'm just left with m. So from this point, I'm going to write the negative 8 as a fraction so I could see some cross-canceling. So see how 2 ends up going into 8 4 times. Notice how the two negative signs are going to end up canceling, and that's how I'm getting m equals 36. So now it says that, and that represents the number of minutes he has left to bike. Now, it said Ed replaces the 2/9 with 0.2. Will he get the same answer? So if we do that, we could go ahead and actually do the work and see what we end up getting. So 28 equals 36 minus, and then he put in 0.2 in place of the 2/9. So what we're to do is just solve the equation again. So we know the first step is subtracting the 36 from all sides. We get negative 8 equals the opposite of 0.2m. Make sure again you're bringing down those signs as you do the problem. Now we're dividing by negative 0.2. Now when you divide by the negative 0.2, we've got to move that decimal point over in the divisor so it becomes a whole number, and move the decimal point in the dividend the same number of spaces. So we're basically adding a 0. And so we're really doing 2 into 80. Notice the negative signs are canceling. And so we end up with 40 as an answer. Well, 40 minutes is not the same as 36 minutes. They do not equal. So why are they different? Well, basically, if we look at 2/10, that's not the same thing as 2/9. If I went ahead and divided 9 into 2, I end up getting a repeating decimal. Notice how 9 goes into 2 0 times, and we have 90 left over, and 9 goes into 20, oops, not 9 left over, but 2 left over. 9 goes into 20, we have 2 times, and we get that same number repeating. So it's going to be 2 repeating. So 0.2 is less than this 0.2 repeating, because the 0.2 repeating continues to repeat. So we can just say, for instance, that no, the answer is not the same, because 2/10 does not equal 2/9, and we showed that up here. And now we'll take a look at our next problem. So the next problem says that Sue wants to have 4,000 in an account. She already has, or currently has, 2,800, and she's working 4 days each week. And so suppose Sue earns $8 a day. So $8 a day, we're going to write an equation to determine how many days it will take her to have $4,000. Remember to define your variables. So let's do this. Let's say, let D equal the number of days worked. And that's what we're trying to find, because that's the question. Always, whatever the question is, how many days will it take Sue to have this amount of money? So we're going to say D equals just the number of days she's working. And so from this point, we'll go ahead and set up our equation. We're going to say $8 each day. So if we do $8 times the number of days, and then plus what she already has. She already has 2,800. So she doesn't have the total amount, so she needs to add an amount that extra that she'll need to earn. And that's when she's working a number of days times the $8 a day, and it'll equal 4,000 eventually. And so now they're saying, well, solve part A. And so we've already written the equation. Let's go ahead and rewrite it again. 8D plus 2,800 equals 4,000. And so from this point, what we want to do is we're going to subtract that 2,800 from both sides. And then from this point, we can go ahead and rewrite our equation. We've got 8D equals, and then I'll end up getting two zeros. I got to borrow a little bit here, and so we end up with 1,200 equals 8D. Now we're ready to divide by 8, and we get our answer. So D equals, off to the side I'll have to set up my division, and it goes in there. Oops, let's see here, that's 1,200, so we have 1. We subtract, we get 40 left over, so that makes 50. So 150 days. That's the number of days she'll have to work. 150 days Sue needs to work to earn the money, $4,000, or to have $4,000, we'll say. That way, because she's going to end up earning less than that $4,000, but she already had some money, so that's why. We'll keep it at that. And so again, she's only working the 4 days each week, but this is the number of days she's going to end up needing to work. So check out part 2 for number 3 for the performance task.